Hello everyone, in this video I'm going to discuss the example for limits and also the asymptote. Given the question we have y which is equals to 2x over the square root of x squared minus the 9. So by finding the limits appropriate point, obtain the vertical and also the horizontal asymptote. Then if possible, we can make use of the situation given to sketch a graph. So first what we have to do is to find the domain. So let's focus on the domain. In here, we have 2x over the square root of x minus the 3x plus with the 3. So for this case, it is all real number because it's a linear case. For the bottom part, we notice that we have the SET. So in here, the SET must be greater, actually is equals to 0. But for this case, since the SET is in the denominator, so we have to ignore the equal sign. So we can say x minus the 3, x plus with the 3 greater than 0. So determine the sign, we have the positive. Then we say x is greater than 3, x is greater than negative 3. By referring to the number line, we have negative 3 and also the 3, empty circle, then here we have the negative, negative, negative. So positive, negative, positive. So we prefer the positive based on the situation given. So the domain would be negative infinity until negative 3 union, start from 3 until infinity. So that would be the domain for the graph fx. Continue for the second step is to determine the xy intercept. So here we have x-intercept when y is equals to 0. So when y equals to 0, automatic x is equals to 0. In order to find the y-intercept, x must be equals to 0, and then we will have does not exist. So actually both also does not exist. Reason refers to the real number line. So here we have negative 3 and here we have 3. So based on the domain given, actually here we have the graph. Same goes to this part, but not for this part. Kindly refers to the x-intercept. When x equals to 0, y also equals to 0. So based on the situation given, here does not have any graph. So we can say it does not exist as well. So back to the story. So let's say refers to the real number line. Here we have the suggested value, negative 3.001. So here we will have the situation, negative 2.999. For this part, we will have 2.999 and here we have 3.0001. Step number 3, move on with the vertical asymptote. So here we have x is equals to negative 3, x is equals to 3. Limit when x approaching negative 3 from the left, limit when x approaching negative 3 from the right. Again, limit when x approaching 3 from the left, limit when x approaching 3 from the right. Kindly substitute the function given. So here we have So now move on with the calculator. So kindly key in the function given. Next, substitute this value and we will have the situation negative 3.001 as the limit when x approaching negative 3 from the left, the value will be negative infinity. Continue, negative 3 from the right, if we substitute this value and we will have does not exist. Next, for 3 from the left, substitute this value, again we will have does not exist. And then finally, limit when x approaching 3 from the right, if we substitute this value and we will have the situation positive infinity. So the meaning positive infinity means that the graph increasing as they approach the 3 from the right. Same goes to the negative 3 from the left, they were decreasing. So vertical asymptote are x equals to negative 3, x is equals to 3. Next, we are going to move on with step number 4, the horizontal asymptote. Limit when x approaching negative infinity. For the situation given, focus on this part. We have to factor out the square root of x squared. So here we have x bracket the 2 over, we have to factor out the square root of x squared. So here we have the square root 1 minus 9 over the x squared. So refers to the negative infinity means that here we will have the negative x. So rewrite the situation So here we have x bracket 2 over, here we have negative x square root, we have 1 minus 9 over the x squared. So kindly refers to the situation. If we substitute negative infinity, here we will have 0. So refers to the situation, then here we will have negative 2 over the 1. So here we will have the horizontal asymptote y is equals to negative 2. Next, move on with limit when x approaching positive infinity. So repeat the situation. Here we will have x instead of negative x. So square root 1 minus 9 over the x squared. So if we substitute, here we'll obtain 0. Then for this part, we will have the 2. So horizontal asymptote, y is equals to negative 2, y is equals to 2. So for extra situation, let's say we want to sketch the graph. So here we have the y, here we have the x. Kindly refers to the domain. Here we have the negative 3, negative 1, negative 2, and negative 3. So 1, 2, and 3. Continue. Refers to the second step. We have no intersection between the x-axis and also the y-axis. Number 3, vertical asymptote. Negative 3 from the left, the graph will be decreasing. Negative 3 from the right does not exist, so nothing happened. 3 from the left, nothing happened. 3 from the right, so we have increasing because of positive infinity. Next, move on with the horizontal asymptote. Negative 2, let's say here we have negative 1, negative 2. So y is equals to negative 2. As x approaching negative infinity, we will have two possible, either above negative 2 or below the negative 2. Again, 1 and 2. So here we have y which is equals to 2. Again, we have two possible, above the 2 or lower the 2. By referring to the calculator, you have to key in this function and then substitute the value when x is equals to negative 50. And we notice that we have the value lower than the negative 2. So the graph will be something like this. Again, repeat the situation by substituting the x which is equals to 50. And we notice that we have the value y which is greater than the 2. So the graph will be something like this. So that is the graph for the fx, or we can say 2x over the square root of x squared minus the 9. So do remember, the graph sketching is just for extra information, how we make use of the information given, or also the information we have to sketch the graph. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share, and subscribe.